Hello everyone, I am Ganesh. I wish to share an interesting real world problem along with the live demo and solution. In India, petroleum and natural gas are mostly transported through pipelines which are maintained by PNGRB. In Tamil Nadu, there are several petroleum container headquarters. Some of them are under construction as shown in the figure. One of the main headquarters is in Chennai. One day, the Chennai headquarters burst and PNGRB needs to predict which headquarters will burst next and how to protect them. In the map of the headquarters and their pipeline connection, we can infer the spread of the fire. Based on the graph, we can determine the distances from Chennai to other headquarters. We understand that the fire will reach the headquarters that is closest to the starting point. Therefore, we focus on the sequence of headquarters with the minimum distances. According to the graph, Chennai has 3 directly connected headquarters. Trichy, which is 332 km, Sankari, which is 380 km, and Kochi, which is 690 km. Among them, Trichy has the minimum distance, indicating that the fire will reach Trichy first. Once the fire reaches Trichy, it will also cover a distance of 332 km through other paths. From Trichy, there are 2 potential paths to new headquarters. Karur, which is 82 km, and Madurai, which is 139 km. Thus, the total distance from Chennai via the Trichy-Karur path is 332 plus 82, which is 414 km, and via the Trichy-Madurai path is 332 plus 139 equal to 471 km. Which headquarters will burn next? It is straightforward. We have a distance of 380 km, 690 km, 414 km and 471 km. And the minimum is 380 km, indicating that Sankari will be the next headquarters to burn. Now that the fire is in Sankari, we have a path to Karur. However, we face a dilemma in determining which path the fire will take to reach Karur first. By calculating the distance from Chennai via Sankari, which is 380 km plus 70 km, we obtain 450 km. As a result, we have 2 distances to Karur, and the minimum is 414 km, indicating that the fire will follow the Trichy path. We can continue this process to identify the subsequent headquarters that will burn. This approach naturally leads us to the Dijkstra algorithm. Let's explore what it is and how it can solve this problem. Dijkstra algorithm is a classical graph search algorithm, widely used for finding the shortest path between 2 points in a graph. The algorithm begins by selecting the starting point, in this case the Chennai headquarters. It then proceeds to search for the shortest path from Chennai to other headquarters. Employing this algorithm can assist PNGRB in predicting which headquarters are at a higher risk of bursting and devising preventive measures to protect them. Let's see how to do this algorithmically. Our starting point is Chennai, which is burnt. The fire has now reached Chennai. So, the shortest distance between Chennai to Chennai is 0. We don't know about the other stations yet, so we update the first row of the table. The distance between Chennai and Chennai is 0, and the distance to the other headquarters are infinity. The fire is going to spread. From Chennai, 3 pipelines directly connect to 3 other headquarters. Trichy, which is 332 km away, Sankari 380 km away, and Kochi 690 km away. So, the fire will first reach Trichy and burn that headquarters. But at the same time, the fire will also pass through the other 2 pipes and cover a distance of 332 km. In the second row of the table, we update the respective distance from Chennai to the other headquarters. Trichy 332 km, Sankari 380 km, and Kochi 690 km. Here, the minimum distance is Trichy, so Trichy will be burnt next. The fire now is in Trichy, and Trichy connects 2 other headquarters, Karur and Madurai. So, the total distance the fire reaches Karur from Chennai is 332 km plus 82 km, which is 414 km, and for Madurai is 471 km. We update the third row of the table with the known distance with respect to Chennai. Trichy has already burnt, so we leave that. Sankari is 380 km away, Kochi is 690 km away, Karur is 414 km away and Madurai is 471 km away. Here, the minimum distance from Chennai is 380 km, which means Sankari is going to burst next. Now the fire is in Sankari and we have a pipeline connection to Karur. So the total distance from Chennai to Karur via Sankari is 380 km plus 70 km, which is 450 km. We already have another pipeline connection reaching Karur via Trichy, which is 414 km. So the fire will reach Karur via the path with the minimum distance, which is 414 km. Next, we update the respective known distance in row 4. Karur is 414 km, Madurai is 471 km, and Kochi is 690 km. The minimum distance is 414 km, so the next burned headquarter is Karur. Now, the fire is in Karur and we have some pipeline connections. The newly obtained information is the distance to Coimbatore. So, the total distance from Chennai to Coimbatore based on this path is 414 km plus 131 km, which is 545 km. We update the next row with the known distances. Madurai is 471 km, Coimbatore is 545 km, and Kochi is 690 km. The minimum distance is Madurai, which is 471 km. So, the next burned headquarter is Madurai. Now, the fire is in Madurai, and from Madurai, there is a path to Coimbatore with a distance of 217 km. So, the total distance is 471 km plus 217 km, which is 688 km. We already know another path to Coimbatore via Karur, which is only 545 km. So, we take the minimum distance, which is 545 km. We update the known distance in the table, 545 km for Coimbatore and 690 km for Kochi. The minimum distance is 545 km, which means Coimbatore will be the next location to be burnt. Now that fire is in Coimbatore, there is a path to Kochi. The total distance via Coimbatore is 545 km plus 190 km, which is 735 km. We know there is another path that has a distance of 690 km. Therefore, we take the minimum distance of 690 km and that is the last headquarters away from Chennai, which will be burnt next. Using Dijkstra algorithm, we get the sequence of burnt headquarters: Chennai, Trichy, Sankari, Karur, Madurai, Kovai, Kochi. For verification, I carried out a practical demonstration by constructing a scaled model to depict the situation. I marked the headquarters on a thermocol sheet with the respective distances using a scaling concept of 1 cm equal to 10 km. Then I connected the headquarters with kerosene drenched thread to represent the pipeline connection based on the map. Finally, I set the fire to Chennai and observed the flow of the fire and the burnt headquarters, which matched exactly with what we obtained from Dijkstra algorithm. Some issues. If the pipelines cross each other, then Dijkstra algorithm does not work. It only works for a complete graph. To handle such situations, we use Dijkstra algorithm. Dijkstra algorithm does not work for negative edge weighted graphs. I'm really happy to have used this simple algorithm to solve practical problems in real world model. Thank you so much.